projects. My name is Jim Wooley. I'm a senior delivery principal with Slalom. We're an international consulting firm with more of a local model, so we're working in our, if I have a customer, I'm out of Atlanta, so if I have customers in Atlanta, I'm working directly with Atlanta. I'm not being shipped off across the country or around the world to be working on projects for other people, for other customers. We do have an office in the southeast in Atlanta, in Raleigh, in Charlotte, in South Florida, so down in the Fort Lauderdale, Miami area. I don't think we have anything in Jacksonville yet. I haven't heard. So if anybody's really interested in consulting, feel free to talk to me afterwards, and we can see what we might be able to do there. So this is going to be in C#, past, present, and beyond. QR code will take you to the link to the content. I already have all the content and demos available on my GitHub, so don't feel like you have to be furiously writing anything down while we're going through this. Take it, play with it, use it at your leisure, and if you have any feedback or questions about them, it is a GitHub, so I accept pull requests. If anybody does find a bug in there. Sometimes I will intentionally leave bugs in my code because one of the best ways of learning is by fixing a bug that somebody else has, right? I originally started learning how to program by, yesterday somebody was mentioning using Commodore 64. And so typing things in Compute Magazine and typing that like 5-page article into the computer and then trying to run it, finding it didn't run originally, and then how do I get that to be fixed? So best way to learn is by doing, right? So I'll try to expose you to a lot of things. I don't expect you to take it all in, but maybe hopefully by the end of today you'll have a couple of things that you'll be able to take out and start using tomorrow or whenever you get back to your work, right? I don't put my email address on here, but if anybody wants to contact me over email, just jimw@Slalom, Slalom like skiing. I'm happy to have those conversations. So, just jump right into it. A little bit of the history of C#. C#, how many people started with C#1? Back in, originally it came out in sort of a PDC 2000, I think it was, and then originally it shipped in 2002 with .NET 1.0, right? And so that was sort of the beginnings of C#1, also VB7 at that point. Some people like to call that virtual Fred rather than actual Visual Basic because it was so far different from VB6 was at the time. Then in 2003, there was the .NET 1.1 release, but there wasn't really language features. So 2005 was the next language version that came out. In 2005, that included generics, iterators, anonymous delegates, nullables. So generics, we knew about list of T, but nobody understood at that point why you would use anything else in generics. We know that that's expanded a lot since then, right? And we use generics all over the place now. Iterators, nobody was writing their own. Anonymous delegates, we didn't understand what a delegate was, let alone an anonymous delegate, so why should we care about it at that point? Well, our lives have changed a little bit since then, right? Because then in 2008, what came along in 2008 with C#3? Link. I loved Link so much I wrote a book about it, right? And so you get Link with lambdas replacing anonymous delegates essentially, and we used lambdas all over the place. Link was sort of the gateway drug to functional programming for C# developers. And so auto properties, extension methods, expressions, and fine. Then 2010 was the next version, and we had really 4 things. Parallel was the one that we use. All the other ones were to make it easier to work with Office. 2012, there was essentially one feature that was added to 2012. Anybody know what that one was? Task Parallel? Task Parallel was actually in 4, so in 2010. But there was something related to Task Parallel. Async and await, right? And they really needed that to be able to do Windows 8 apps, which everybody all wrote Windows 8 apps, right? So 2012 came along, that was the next one. The next release of .NET was 2013. Anybody remember what language feature happened in 2013? No. Then 2015, this was the big one. So in 2015 was the next real big release, and this was a huge release. This was when Roslyn came. They had been working since 2010 on rewriting the compiler and rewriting the C# compiler in C# and the VB compiler mostly in VB. Because previously, a lot of it was written in C++ and some in assembly even. And it was becoming an unmanageable nightmare to be able to maintain and add any feature and functionality to. So they were dog fooding it as they were going here. They also were doing things like enabling the visibility into the entire abstract syntax tree so that other people would be able to write analyzers and such. And if you missed the analyzers talk yesterday, hopefully it was recorded so you'd be able to see that. But you'd be able to leverage that and be able to write your own analyzers and pieces not only that the Visual Studio team needed to be able to plug into the infrastructure, but to support others to be able to plug in and add more features onto. But while they were dogfooding that, they found that there were a whole slew of things that were useful and said, hey, it would be nice if the language supported this, or it'd be nice if we could do that kind of a thing. There was actually one feature in Visual Basic for multi-line strings which they found, oh, if we just comment out this one line of the compiler, we're going to enable that. And everybody's been asking this for 10 years now. Maybe it's time to actually do that, right? They did find there were a couple of places in here where the spec didn't agree with the current implementation. And so do we change the implementation or do we change the spec? Because if we change the implementation, it may mean that your code that you've written that took advantage of this obscure side effect will now break. And so they actually coded into Roslyn those breaking things, so they didn't break your code, they actually made it work the way that people expected it to work. So that was in 2015. We had all sorts of C#6 stuff, and we're going to be covering each one of these in depth, so I'm not going to go too deep into what are all of the names of these things. Seeing it in use rather than seeing the name is probably going to be more important, right? So we had, in 2015 was C#6, and then end of 2016, we had C#7, and with 7 was the first time we got point releases to the language as a specification. We actually had 3 point releases within about a year and a half of C#7. And around the same time was when Microsoft started to announce that, oh, we have an annual update cycle for .NET, and the languages are probably going to come along the line with that. Additionally, with .NET 8 or C#8, they started adding more and more cases where you have to have the latest version of .NET in order for this language feature to light up, right? And so some of the language features that I'm going to be showing you today, you might not be able to take advantage of if you're still like on .NET Framework, which goes to, all the way up to .NET 4.8, or if you're on an earlier version of .NET Core. So when we get to C#11, there are cases where you have to be on .NET 7 in order for this feature to work for you. So just be aware of that. So C#8 had its own things. At the bottom here is actually links to the language team's resources. One of the other things that happened with Roslyn is they open sourced C# itself. So if you want to see how the compiler works, if you want to contribute new features to the compiler, they enable that. They have accepted community pull requests. They do have a process that they want to make sure to vet. And if you have a proposal that you have that proposal written up of here's what I want to change to the language, and they're going to have conversations over whether or not that makes sense. So just because you love JSON doesn't mean you're going to be able to inject JSON literals into C#, right? They have certain bars that they want to make sure that they meet. But they have expanded quite a bit. You saw previously that it sort of slowed down on language evolution. Now that they're using it internally, it's speeding up. And some of these speedups, particularly in the 7.0 period, there are things that you may not use yourself very often. These may be things that the framework needed or that really required high performance improvements. Because there were really lots of performance improvements with .NET Core that have happened over the years, even between .NET Framework and .NET Core 1.0, right? If you looked at the Tech and Power benchmarks for .NET, and if you look at Tech and Power benchmarks, which is sort of a industry-wide, they go to C++ language and implementations and JavaScript and Ruby and all of these various languages and try to see what's the performance of all of those compared to the other ones using standard benchmarks. If you looked at it for .NET Framework and the old classic version, do you know where that version ranks on the top 100 of the benchmarks? It doesn't. It's under the top 100, so it doesn't even rank. .NET Core 7 is up in the top 10. And pretty much the only things that are beating it are native C++ libraries that are really dedicated purpose type of things. There may be a Dart one in there as well. Node is an order of magnitude slower than C# is in .NET Core at this point. There's a Python in the top 10. Yeah. So, I mean, it can continue to, and there are multiple benchmarks as well. So there's one benchmark that says just how fast to just load a static page. I just blanked on the name of it, but there's a futures benchmark which does data access. So basically it's more of a full stack one. That's probably a better benchmark to take a look at, just to see. And they're constantly reevaluating as new frameworks come out as well. So did a lot of performance improvements. A lot of the things with 7 and this point releases really got around, actually accessing pointer references and changing how some of the low-level things were happening under the covers there. And so you're probably not going to be leveraging some of those. So I'll probably skip over a lot of the 7 stuff. I'll just point out a couple ones here and there. But there were a number of things there. 8 has some controversial stuff in there. We'll take a look at those. And then 9, number of new features inside of 9. Some of these features are starting to get to, let's make it easier for new people to come in and learn the language. Because when we had to do Hello World as a project new app, console application and such, you have to do a class and a namespace and using clauses and all this extra stuff before you can even actually get to let's write console write line Hello World. And so how do we make that a lot simpler and condense the code that has to be maintained?
I know this is going back a couple slides, but I think 2013 it was 64-bit support, if I remember correctly.
64-bit support from the operating system has been around all the time. 2022 from Visual Studio added 64-bit operating system for Visual Studio itself. So. Compiler was 2017? Okay. So here we have the C#9 stuff. C#10 came out last year, and C#11. There's preview stuff for C#11 at this point. They've already killed one of the C#11 features due to community backlash against it, which I think is right. I didn't agree with the direction the language going, but that's an interesting thing about. Since they're doing the language in open source and open conversations, they have open language design meetings that anybody's allowed to attend, and they're getting that feedback more immediately. So they can say, well, we're thinking about doing this. What do people think? Is this the right solution for that? There was a feature that they proposed, I think, for C#6, which was auto-implemented constructors or something like that, which in the last minute they pulled because it wasn't the right solution, and they still haven't put it back in yet because they haven't found what it feels like the right solution. Records is probably the closest thing that they've come to that one at this point. So lots of stuff here, and I think at this point it's probably going to be best if I just jump into some code so you can see what these things actually are and what they mean, right? So I have one solution. In this solution, no, not the properties window. Properties window go away. Here we are. In the solution, I have folders essentially for each version of the language with samples of how does this particular language feature work in the sample. So if there's a particular one you want to take a look at, you can dig into this. Also online on the docs at Microsoft.com, they have drilled down into all of these and with also links to the language specification. So if you really want to get deep on any of these, there's plenty of resources out there for you to jump into. So I'm going to start with C#6. And in the next 45 minutes, see if we can jump all the way from C#6 to C#11 and what I think are the features that you're probably going to want to take advantage of and use on a day-to-day basis. So first one, we've had auto properties for a while since C#3, but initializing the auto property, you had to put that initialization separate from where your actual declaration of it was. So we said, well, let's go ahead and add auto property initializers for the auto props. And since we do that, then we don't need a private setter for that. We can set that right in line and remove the setter entirely here. Now this actually compiles the same way that this one would without the initializer, in that we can initialize that in the constructor and in the constructor only. So if I tried to initialize that anywhere outside of the constructor in this class, it would not allow you to change that value. So this is the very beginnings of how do we get sort of immutability in C#. And trying to guarantee that that's going to happen there. Okay, then the next one is importing static. So sometimes you have a number of places where you might want to import, but if I want to import, you can't import a static class. Sort of an oversight. So console is a static class that has static methods on it. Math is a static class that has static methods on it. And so I write console write line, console write line. Why should I have to write console all the time? Maybe it should be easy for me to do it without that console. Well, they added the ability to have at the top here using static, and now I can import a static. Now realize that if I'm doing both console and debug, that both have write line, how do I disambiguate between the two of those? And so then you're going to have to be a little more explicit in it, right? But this also allows things like, instead of doing 2 times pi times radius, I can just do math.pi, I can just do 2 times pi times radius. Less things that you cognitively have to look at, and this just makes the code flow as you would think of it from a mathematical perspective, right? So that's helpful. There was a gap in the language where you couldn't do adding exception filters to be able to do stuff. And at this point, in the catch, try is not a performance hit. Catch is a performance hit. Because when catch hits, it has to basically pause the executions, evaluate the entire expression, the tree that's coming into it in the graph, and rewind the call stack and things like that. So if we can then have an exception filter that says only filter it if this is the case, then I don't have to have that performance hit as much. And I can optimize that a little bit more. There is an interesting one where you can use this for logging as well. And so that if all I'm trying to do on my catch is do a log, do that through an exception filter, and then your life is going to be a lot easier. Performance is better. They also added something around async inside of catch blocks, where you couldn't do async inside of catch blocks before. And there's actually a lot of work. If you want to look under the covers on this one, there's a lot of work that happens under the covers to actually make this work. But they made it easy for you as developers to be able to do that. So for example, if you're trying to log information to your database when an exception occurred, but you don't want to hang your UI up, you want to do that asynchronously, now you're able to do that async in here. Let's see here, what's next? This one I use all of the time, string interpolation. So we've probably all written code that looks like this, write line with a string format. We have 1 is 2 years old, and we have a first parameter and a second parameter, right? What's wrong with this code? It's 0-based index rather than 1-based. So this compiles fine. Compiler says, sure. Now you get a runtime exception, and trying to find where the source of that runtime exception is painful. And it's the most expensive thing is to fix a bug that happens in runtime rather than compile time. So they actually have tooling that allows you to say, we have an invalid placeholder now inside of Visual Studio. So it's doing analysis inside of the string and finding problems that are inside the string and allowing you to fix it that way. So here I could fix that. In fact, I'm going to say this is whoops, new laptop, keys in the wrong place. So I can do that. But also, we still have these magic strings and magic numbers inside of here. Wouldn't it be nice if we could just go ahead and convert this to an interpolated string and have things directly inline? I'm not sure why it's trying to convert those as object. That's a new one. I've never seen that before. So now we can have it right inline in the string. And one of the cool things about this is I can now get IntelliSense over the code that's inside of a string. And the compiler can check to make sure that you're not calling things that you're not supposed to be calling on that. I can also, similar to what we would do with like ASP.NET, I can then use formatting strings on those. So birth date and format my date in this particular format. And I don't have to do all sorts of additional workarounds to do that. Do be aware that if you're using something like link, that link doesn't necessarily interpret what's in your string interpolation. Although if you're using Entity Framework does have a from SQL raw and from SQL interpolated. And if you're using the from SQL interpolated and you're doing an interpolated string directly in that from SQL interpolated, it will translate those interpolations into parameters. So always use from string interpolated, not from string raw. so you don't have to worry about SQL injection attacks at that point. Another nice one that they added was name of. So if you've ever had the case, for example, where I have an on-property change and I do a magic string of the property name, and then let's say I go in and I change name to be name 1 and do a refactor rename, notice that that magic string didn't pick that up, right? But if I do name of, it will then make that as the same string, but now I have refactor aware types of behavior in there. So it just makes it a little easier rather than using magic strings. It's really great for argument exception as well. Then they also added in the ability to have more functional programming. I said LINQ was the gateway drug to functional programming. We can start making it more and more functional as we go along. So here we have with the lambda saying this is a method and it returns this. It's essentially the same as doing this method right here, but we can shorten that to this syntax. And that's for a method. If I wanted a property getter, I just exclude the parentheses. And so that's a property, the other one's a method. Okay, I'm going to jump off of C# 6 unless anybody has questions about any of those, and jump to C# 7. C# 7 got one method that has all sorts of C# 7 stuff inside of loaded inside of it. First one, kind of an interesting one. If you have long numbers and it's hard to see them conceptually, they now allow you to add digit separators and binary indicators on those numbers. It translates to the exact same number without it, but it's just easier for a developer to be able to see that and line that up a little bit better. The next one is tuples, so adding tuple support directly in the language. So now I have a method, which is a local function. Now we're making our C# look more like JavaScript, right? So we can declare functions inside of functions and nested those, and we can also recursively call those functions inside of their own function. And this returns a type which has more than one property, but I don't want to have to go out and create my whole class and all that extra plumbing. Let me just declare that more in line to say that this is going to return something that has two values rather than one value. It's a tuple. And that tuple also can be deconstructed so that elsewhere I can then say, well, I'm going to create a tuple. I'm going to call my variables s and c here. It's going to get the value result from this tally method. Here's that recursive call I was talking about. And, well, by the way, I want to name those differently because, whatever your reason is, you can name it however you want to name it. Just be aware that the positioning and the typing have to align. And you can do this outside of tuples as well. As long as you have a deconstruct method on your class, you can leverage this language feature. It's sort of a duck typing type of implementation here. So we have tuples. In this tuples, then we also started seeing the beginnings of pattern matching, particularly pattern matching in switch statements. So here in a pattern match, for example, I'm going to say switch on V. V is an object. And if it's an integer, then cast it to a variable, a local variable we're going to call I, and allow me to use I in the context of the body. If it was an enumerable of any object, when I have something in it, then do this. Cast it and get the value. If it's a string, then try parse that, and if that try parse works, then use that. Oh, and by the way, with try parse or any out vars, where you have to declare the variable outside of the method, and it's the whole pain of trying to figure out where you're declaring it. Now we can declare it right in line, which is another great feature that was added in C# 7. And if you have your method that doesn't do this, there's actually an analyzer in CodeFix that says, hey, I see that you could take advantage of this. Maybe you might want to go ahead and do it. Control dot it, find the solution for it, and just go ahead and use that. Okay. Yeah, it's good. So here's some more other examples on pattern matching. Before we had pattern matching, we had to basically allocate a variable and then say if P is employee, then we're going to cast it as P. And so we have the is does a cast and throws the result away. So here we're going to do a cast, throw the result away, and then do the cast again. So little performance issues with that version of it. We can also do P as employee, and then if it's not null, then use that P. But now what we can do as of C#7 is declare it right in with a pattern match and say, if P is that, then declare a local variable however we want to consume that, and then consume that directly. So code becomes more concise. We're not dealing with the multiple casting issues and performance hit over multiple casts and things like that. Okay, that's ref local. We already talked about that one. They also added in throw expressions. So, for example, this is useful with doing null reference exception, where you do a check. If string is null, then throw a null reference exception. Well, they added the ability to say, create a variable, which is t, and say if s is null, essentially, then throw the null reference exception. And then, otherwise, we can just go ahead and use t. A little more concise. It's good if we have multiple chains of checking the input parameters for nullability, for example. Okay, that's good for C#7. Let me jump to 7.1. As I said, the dot versions of C# start to have a little bit less in terms of what you're going to use day to day, more performance optimization. So I'm going to fly through these quickly. First one, if you're doing async, you know that you have to basically, once I start async, I have to go async all the way up, right? If you're doing a console application, you couldn't do async all the way up because main couldn't be async. As of C#7, you can now do async main. There's also the ability to say, well, we have person equals new person. Why do I have to do all of that? Maybe I should just do person equals default. It will create a new person by default because it knows that it's supposed to be a person. So that makes it a little bit easier to do those kinds of things. There's actually an optimization that we're going to have over functions that's going to come, I think, in C#10, which will make that a little bit easier. That's as far as I want to go there. Changing on tuple types and how they align and equality on tuple types. Yeah, that's fine. C# 7.2, things about how the parameters are evaluated and the ability to do things which we should have been able to do all along in terms of if I get into a parameter chain and doing those out of order, or which ones were allowed to be the null ones and not the null ones. And so there's a little more flexibility in there. You're jumping into C#8. Oh. Yeah, I mean, this particular solution has everything, and this has the C#8 feature enabled as part of it. So you may be finding a C#8 thing going on there. There was a gap where that leading the digit separator from C#6 that we saw, or C#7, sorry, didn't support it if it was the first character. So I'll allow that in first character too. A compiler update. And C# 7.3, they added the ability to have generic constraints on delegates, enums, and new, which they didn't have before. Whether you care about that or not, maybe not. Tuple equality, expression variables inside of links. So these two expression variables are sort of filling a gap where somebody said, oh, I love using expression variables, like the outvar here, but I can't use that in a initializer. I'd love to be able to use that in an initializer, which is a gap in the compiler. And so they said, okay, we'll go ahead and enable that there, and also inside of link expression. So here we have the try-parse with the outvar inside of a link expression, which is just filling a gap there. Small stuff. Okay, C#8. C#8 has some interesting stuff. It has some controversial stuff. It has some stuff that you may or may not want to use, depending on your application. So we'll try to jump into some of these. One of the first ones in C#8 is a case in particular where we started to say, you have to have this version of .NET Framework in order to use. Not for everything, but for more things. And they're doing that more and more in newer versions of C# as well. But with this one, it required a new interface, async enumerable, async enumerator, to be able to support async enumerables. So think about if I'm iterating over a collection of things, and anytime I move to the next one, I need to make a service request to get the details of that thing, right? That's going to be an async that I'm going to have to await on as I'm doing my enumeration. And it can be painful to do inside of a for each clause. So they added an iasync enumerable, which then includes the async move next async method as part of the interface. And so now as I'm moving through that, I can then await that move next. And then a language feature to be able to support that is to be able to add await to for each. And now automatically it's just going to go ahead and await on the results of those things that are coming in. Interesting. Not controversial. Ranges. This has some good functionality, and there's some performance optimizations that happen here as well. So we have an enumerable range, numbers 1 to 10. Maybe I want to get the first two values of that. So now we have range indicators to say ... So we take a range starting with position and then ... to another position to get those ranges. So here I have ... which gets the first two values. Or I can do 2 ... 4 to get from position 2 to position 4. Or I can do with the caret to say take from the end, so to get me the last 4 to the last 1, right? And so it's really good to have that. Then the array, they also added the span of t. And whereas an array, when you're doing some of the range operators on an array, it's then going to take a copy of those values and move those out. With span, it's actually doing memory pointers directly to those positions inside of the existing array and not making a copy of the array. So there's some good performance benefits that they made on the span of t at that point. Now this, where would you use this? Here's an actually really creative way of using this. What about string parsing? So I have a long string. I want to get certain characters within that string. So instead of doing the length and the substring and all those hurdles that we typically do, let's just say I want to get the word text out of this. So I can do an input with a range of starting in position 10 through 14. Or I want to get the end of this. So I can do caret 6 to get the last 6 characters of that, right? And so there's some other interesting kinds of capabilities that you'd be able to leverage with this. This does require .NET 7, I believe, was the C# 8 at that point. Or that was .NET 5, I think, for the range operators. Okay, not controversial. This was a one that I use a lot as well. So typical using clause, we have to do a using with a block, and then everything inside of that using gets indented and makes our code a little messy in terms of the indentations. So they said, well, we can just do a simple using without the block, and then anything else in that block, in the context of the block that was declared, it will stay in the context, and as soon as we go out of the declaration of that method, we'll go ahead and dispose that value. Just a little tweak there. And with this one, if I do control dot on it, it says, do you want to use a simple using? So yeah, we can go ahead and apply that pretty easily as well. Not controversial. Switch expressions, they added the ability to do a switch expression, which, if we're doing something, we're doing a switch, and then each one of those is just returning a value. Well, how about if we just assign that value as a switch expression to be able to get it to option, whatever that option is, and then switch on that to do what we need to do and get the result of that value from each one of those. So that's an interesting one that you can use. So here's the old way that you would have to do a validate method, for example, where I get a string. I have to check to see if I have a string. If not, then I'll check the result. And if it's one value, then I get one output. Now we can simplify this all by saying we return the x value, switch it, and if it's null, then throw a null reference exception. If it's error, return known bad. If it's test, return known good. And you can have evaluations inside of this that says if the length is greater than the x value, too short. If it's smaller than that value, too short. And this underscore is sort of the default placeholder that says otherwise, do this. Right? So which code do you want to write? This one or this one? And if you like functional as well, we can also take advantage and do expression body to make it even easier. Okay, still not controversial. I'll do null reference exception next. So null reference exceptions are the bane of our existence. There are people on the C# teams and .NET teams that said, If we had our druthers when we wrote C# originally and we wrote .NET originally, we wouldn't have allowed you to have things as null. Because null checking is a pain, and you have to do it all over the place, right? Wouldn't it be nice if the compiler could help you out here a little bit? And so that's what they've enabled for C# 8. There's a compiler switch or a switch that you can put on the class itself to enable this. But what this is going to do is it's going to check to see, are you initiating everything? And if not, warn you that something might not be initiated and you might need to check it and make sure you're doing something appropriate with it. I need a drink of water here at this point, it sounds like. Okay, so we got a class. This class is an address. It's got address 1, 2, city, state, zip. It's got a constructor. I'm constructing on address 1, city, state, zip, but not address 2. And the compiler is warning me, because I have this feature enabled, that says a non-null property address 2 must contain a non-null value when exiting the constructor. Consider declaring the property as nullable. What's going on here? It's a string. Strings are reference types that can be nullable. What's a reference type? It's an object. Anything derives from object. String is kind of one of those. String is kind of a special case. But it can be nullable. So a person can be nullable, right? A attribute of a person can be nullable if it's a string. If it's an integer, then it's not nullable by default unless you explicitly say it's nullable by adding a question mark, right? So the feature that they added was when you turn this feature on, all strings by default will be forced to be non-nullable unless you explicitly say that they are nullable. Which if you turn this, anybody tried taking this and turning this on an existing code base that had thousands of lines of code? I see some laughs. What happened when you did that? Yeah, you turned it off, right? Because not only does it check it in your class, but it also checks all of the callers to that class and all of the callers to the callers of that class. And it works the entire graph of your application to make sure that it's where it can check it, it's enforcing it. However, realize that serialization doesn't necessarily enforce that either, unless the serializer knows about this feature as well. And so just by saying that I'm forcing this to not be nullable doesn't mean that it might not really be null, or it might really be null. So things to watch out for here. But it's going to try to help you out a little bit. So in this particular case, what can I do? Well, I can initiate that string, but I want to make that so I don't have to initiate that string. So what I can do instead is say, well, this string is a nullable string. And now the constructor says, OK, I'm not setting that. It's nullable. I'm good. However, there's now something else which has popped up that says, I'm trying to consume that without actually checking to see if it was null or not. So at that point, I can then say address question mark dot address 2 and use the null terminating operator, which I think we must have skipped over a little bit earlier here. It's actually address 2 question mark dot trim, right? There are certain cases where the compiler isn't able to check everything. So let's say we've checked it and we know that it has to be actually a value. So they added the ability to actually do bang equals, which says, me as a developer have asserted that this will always have a value, even though it can potentially not have a value, and ignore the compiler, ignore this, so damn it, it's good. And people affectionately call this the damn it operator. So it's up to you in terms of whether you feel like this is good for new projects, and I think the default templates now actually have this enabled by default. But if you try to apply this on existing projects, yeah, you might have some challenges trying to go through your entire code base and making sure that everything is abiding by it as well. So trying to guide you into the pit of success is a good thing. Okay, I say this is controversial. This for me is one of the most controversial ones. So here I have a class, and I have a location class. We can construct that location class, and I added this formatted method to that, which then can get a formatted string of that value. So common kinds of things you might want to do. So here is my location class. It derives from my address, because I want to be able to inject it for mocking or whatever. And I have address 1 to city state zip, and I have the location constructor that takes those things in, and that's the class. But what about that formatted method? Where's that formatted method? Well, I originally created the class without it, but then I wanted to have my interface say we need the formatted, but I didn't want to have all of my implementers go out and add that to it. So I'm now adding a method with a default implementation to my interface. And I can now consume that. Interfaces are supposed to be the contract, not an implementation, right? This is breaking that fundamental object-oriented principle. It has certain uses, granted. I don't know if I like it or not, so this is sort of where it's controversial. You also need to make sure that instead, if I were to say var here, or if I said location here, I would not be able to call into formatted. I have to explicitly cast it as that particular interface. Why? What happens if we derive from 2 interfaces, both of them have the same method? So this handles that overloaded.
Does that compile down to like an extension method under the hood?
No.
Used to do that, right? You've had an extension method for iAddress.
Yeah, I mean, that probably an extension method would be the better recommendation I would have. The only way I've really thought this might be beneficial is at a framework level, or potentially, for example, supporting iOS in Xamarin, where if Xamarin adds a new feature, and everything in Xamarin has to be interface-based, just how Xamarin sort of works under the covers in iOS, that may be part of the reasoning why they added this. I mean, there's a possibility that they could have not used extension methods at all with link, and done all of link as let's extend the default implementation of IEnumerable. I'm glad that they wrote extension methods, right? And supported that. But so it's there. I suspect you're probably not going to use this in your own applications, but it's there in case you want it.
So what is your recommendation? Like, because I see codes coming to me saying that people are writing this standard. People are writing it. So what's your recommendation? I can't go and argue with the...
You can write static analysis tools, which saves an error.
Yeah, but why am I going against the standard is the question. Right?
Because you want to maintain consistency.
Yeah.
The
Yeah.
you guys are writing it. I have to
You put it in your style guide, say no, that you're not allowed to do this, right? Yeah, it's.
I can't go against Microsoft.
Let's have a conversation offline on this one. I said it was controversial when I started, right?
Sometimes they only add things to languages just because all other languages have them.
There is that too. There are some other things that are coming with interfaces as well that might be able to piggyback on some of these items potentially as well here.
It looks like an abstract class for me now. It's like,
Yep.
Yeah, that's weird. I would never.
Yep. Yeah, I would think an abstract class would be better than an interface in this particular case. But with iOS, you can't necessarily use the abstract classes, right?
Is the IntelliSense going to let you discover the method if you declare it as a location? Will it say?
As location, no. As iAddress, yes.
All right, so they're not discoverable at all. You have to go somewhere else.
Right. Okay. Yeah, you want to, they're trying to avoid the multiple inheritance problem, essentially. Okay, that was 8. We got 15 minutes to do 9, 10, and 11. Oh no, this is not, that is not, that's 8. Oh, my C# 9 went into a separate folder here. I need to fix that. Okay, so let's see here. Let me do module initializers first. Module initializers, if you have something where this has to run at the beginning of your thing. There's certain places for like test projects where you have to do this before you do anything else. You can do one and only one method that starts with a module initializer, and that will be run before anything else runs. And we run once. That's at the assembly level. Some more extensions on pattern matching. This one is to make C# look a little bit more like Visual Basic. I was talking with somebody else earlier today on this one. And it's actually the recommended alternative. Typically we would do x not equals null, x equals null. and they recommend instead doing X is object, or X is null, or X is not null. No, X is object does not match null, right? So this pattern match solution is actually the recommended version of doing a null check now, rather than the other one. Okay, the one we definitely have to cover is records. And with records, I'm actually going to pop out to a website, sharplab.io. And one of the nice things about this is it allows you to see what's going on under the covers really easily. So I don't have to compile it and then open up IOSpy or Reflector or one of those kinds of things. It can do it directly inline here. And you can also do this and run it and sort of see what the results are. They're also maintaining this to, if you want to see a specific version of C# or a preview feature which they're thinking about and not even releasing, you can try testing that inside of here before it even makes it into the Visual Studio. But on this one, we're going to take a look at, first of all, we've done classes for a long time, right? Public, auto props, getter setters, and that compiles under the covers to a class, and the class has a getter and a setter with backing fields that you just can't access directly, right? But it's public getter setter. Oh, this is the one actually, for the class P. But they wanted a more simplified way of doing that, so I didn't necessarily have to declare all this. If I'm just going to put it in a constructor and say, go ahead and create one of these things, you can just go and do it. So I can do basically the same kind of a thing if I'm not going to be changing any of the values. And so they wanted this record to be an immutable structure as well, so that we can start to enforce mutability. Once we start enforcing mutability, we might be able to enforce parallelization automatically and some other kinds of capabilities that can come under the covers here. Great for data transfer objects, for example. And with this one, it basically generates the same thing. So here we have the first and the last with the backing fields. Notice, however, that instead of a get and a set, it's get and init. And why is it get and init? With init, it makes it so that I can't, right here it was declaring it from the class version. If I change this to, instead of new P, to new person, then the compiler is actually going to, I need to fix the casing on this one to actually, I can just say, I want, one thing with IOSpy is it doesn't work if it doesn't compile. X equals new person, and these are curlies rather than, or parentheses rather than curly. Come on, mouse. Okay, so this should work, except now I can't change first because it's an initter only. I can only do it in the constructor. I cannot change that value once it's constructed. Yeah, I love extreme presenting sometimes. It still won't like it because I'm not allowed to change it because it's an initter rather than a setter, right? So how can I then take a value and change it? Well, they actually have, instead of this, then I can say var y equals x with, so they have withers, then first, and not var y, but var y equals that. And now I can do the same thing, and we can take a look inside of this to see what's going on inside of that method. And here is what's actually happening internally to that, which is where IOSpy kind of comes in play. So it's actually allowing you to create a new person object and doing a clone on that to the new value and setting that value. So it's actually doing a setter inside of here, but that's only inside of what the compiler generated stuff is. The compiler doesn't let you do that yourself. The compiler has the ability to do, or the runtime still does it, but the compiler doesn't, right?
But the important thing is it's a separate memory pointer, right? It's not.
It is a separate memory pointer, yes. So with C#9, these are classes. With C#10, they supported the ability to have it as a struct, and then you can also do a public record class as compared to a public record struct. and be specific around the two of those if you want class semantics rather than object semantics at that point. They do add a couple of other things in here in terms of particularly equality checking, so that with a class is a pointer equality check to say, is this instance the same as that instance? With the record, equality says, are the properties within this the same values? And so it's doing a property of an equality check instead of doing a pointer check at that point, which is often what you're trying to do anyway, right? So a couple interesting things there with records. Let's see here. Some pattern matching changes to modular initializers, top-level statements. So this is a valid C# class, or valid C# implementation. There is no class. There is no main. This is console write line at its barest minimum. There's no namespace. There's no, I don't even need the using if I didn't want to. I could have, hello world is one line in C# now. You can only have one class in your assembly which doesn't have the class in it, because otherwise it doesn't know which of the other ones are. But I can declare classes inside of this file and have classes in my application as well, which is what I did over in that sharplib example.
So you can run it like JavaScript.
Yeah, yeah. It doesn't care what the order is. It actually compiles it into a class and just sort of stubs in that async main for you as well.
If you had defined an async main, then would it work?
Yeah, you can only have one async main, right?
You still need a project file?
Yes, you do need a project file. But this supports like lambdas and some of those kinds of things as well, Azure functions. So just really trying to get Hello World up and running. So from a training perspective, you may not use this in your own day-to-day, but if you're just trying to play with something, now we don't need to go out and use LinkPad or some of those other tools to be able to just test something and try playing with it. And it's actually the default template if you're doing a console application.
I can just see someone running something like that above their class and ruining someone's day.
Yeah. Well, the compiler will tell you that there's a problem and be able to warn you against it at least. You're not looking at somebody else in the room on that one, are you? There's some optimizations around new expressions. So here, employee equals new employee, or we could do var equals new employee, or now we can do employee equals new. Or employee equals new and with an object initializer on it. Which is kind of interesting, where if we have a method that requires an employee, but I don't want to go out and create another one to do anything, I can just say, take whatever that method is and infer the type and just say, I want a new one of those. And I don't even need to create a new person here or a new employee.
In the non-nullable world, would that be equivalent to being default? Because default should be the non-nullable?
Default would be null on the class.
Test it and see. Okay, 6 minutes. 2 more versions of C# to go. Okay. There are optimizations around interpolated strings. You can take this and put it into sharplib and see that depending on the number of parameters that you have, it's going to generate different code, because at a certain breakpoint, performance is better to do string concatenation as compared to not string concatenation, and automatically optimizing that for you. They had improvements in lambdas. So before, if I wanted to create a variable that was equal to a lambda, I couldn't just say that this is a func of t, because the lambda itself could be either a func of t or an expression of func of t. And you couldn't disambiguate between the two of them. They said, by default, almost everybody's going to want it to be a func of t, and so we'll just go ahead and default that behavior for you and make it easier. So now I can say, I want a lambda, it's going to take in these parameters, and it's going to return this expression, right? I don't have to explicitly cast it as a func of t. Let's see here. Adding constants into interpolated strings is cool. Property patterns, I'm going to jump through that. File scope namespaces. So, I keep talking about trying to condense things over to the left a little bit more. Now, instead of having to have the namespace, we figured that while C# supports multiple namespaces in a single file, nobody does that. So let's just say at the top, we'll go ahead and declare the namespace at the top as a single line, and then we can move everything else on and not have to have a block code in order to block that all out. Make it a little simpler. Global usings. What happened there? Okay, global usings. Here, we have cases where we're wanting to use usings all the time and using across all these little different files. So think about like a test project, and where everything needs to derive from XUnit or NUnit or whatever library it is, and everything needs to have system in it, and everything needs to have entity framework in it, or whatever the libraries are that you're using pretty much across your entire assembly. Now I can, instead of just saying using, I can say global using, and now that's great for one class, but then I come into another class, and there's no using clauses at all in here, even though I'm calling XUnit assert, the fact attribute, the absolute value from the static math class, and all of that's then referring to that static usings, global usings class. My recommendation, have a single file by convention inside of your assembly that is your global usings, and make sure that everybody's putting those there. Don't scatter it out throughout your application, because then it's going to get really confusing to find it. And also, don't put anything that's going to be conflicting, and you have to go and disambiguate way too many times. So use it where it really makes sense. We already mentioned the struct. So by default, the record is a class, but they now added the ability to do struct, because there's sometimes where performance is better as a struct. And then, oh, by the way, will allow you to explicitly say this is a cast. And this actually compiles exactly the same as this does. They also added, anonymous types. Anonymous types by default are immutable. You're not allowed to change values inside of an anonymous type. So they said, well, we have withers now from records. Why don't we just go ahead and allow you to use a wither with an anonymous type as well to be able to create something else that has those particular properties and values. Okay, let's see here. Oh, we can have a little bit of a chat. I do have a business call I have to take at 12:30 though, too. So if anybody wants to hang later, then you're fine. I got you for another 2 minutes and 41 seconds right now. But yeah, I don't want to make you hungry and miss out on lunch either. I know that that's the best way of getting bad evals. C# 11 added the ability to have generic attributes. So instead of doing a non-generic where a type of string, I can now say there's a generic attribute of type string with that. You're probably not going to be getting into this too much, but you may see this start to come across in some of the .NET Framework new language features and support. And in particular, there's stuff around math. In generic, there's an iNumber interface that's coming with .NET Framework 7, or .NET 7 rather. And with that, then I can have a generic sum where I can pass it in a generic of one type and another type, as long as they're considered also to be numbers, like an integer or a decimal or a double or a float or all of those are numbers. We can apply the same kinds of things to those, as long as they all agree by that same interface, which they're actually going to be implementing for all of those types under the covers. Then I can do this generically and not have to build out a separate method for ints and a separate method for decimals and a separate method for, so that's going to make that a little bit nicer, right? They're adding pattern matching for lists. So if I want to say, for example, is 6 in here at all in this list of things, then do this. And this can also be inside of a switch expression and pattern matching. So some of those flexibilities there as well. I can say, make sure that I don't care what those values are, where they start, and how many there are, but as long as they're all less than the value 10, then say that that's a match to that pattern. And there are a lot of other kinds of pattern matching that you can start doing. This isn't just numbers, it's also strings as well. So some pattern matching capabilities. And everything I'm saying in 11 has not shipped yet. It is not guaranteed to ship. Okay. Adding more abilities. So for example, this is a string interpolation. Previously, you couldn't have a hole and have multiple lines inside of that hole in string interpolation. So for example, I want to put a link expression inside of a string interpolated string. You couldn't do that before 11, and now they'll add the ability to do that here. See here, raw string literals are really an interesting one where typically when you do a raw string, and then you'd have to sort of indent all of this and have this all the way at the far right, and it really makes your code look really nasty if you don't want your string to include all those extra spaces in it. Well, this one now I can include that, and what we do is we say that the raw string literal starts with at least 3 quotes and ends with at least 3 quotes. Let's say I wanted to put something inside of here that had 3 quotes. Well, then our placeholder here could be 4 quotes, or 5 quotes, or 6 quotes. And it doesn't care as long as the numbers add up on both sides. And if I want to say, well, make sure that all of this indents 4 spaces, well, I can just have the end of this go back 4 spaces, and now everything inside of that's going to be 4 spaces indented for each individual line. Some interesting stuff in here. This is really useful if you're going to be doing code generation inside of code, for example. So anybody that's played with the syntax generators in C#9 and the source generators, that's where this one really becomes powerful, because you do a lot of this kind of a thing in there. And so this is really going to help out there.
Advanced usage.
Yeah. I have an example here also where let's do a string, an interpolated string, but I want to make sure that interpolated string, I want to have brackets that are in part of the interpolated string. So by the number of $signs means that that's the number of curlies that will indicate that this is an interpolation. It works. Gives you the flexibility. Okay, so one last one, and then I am going to have to call this one a day. And actually, let me do 2. So I said not everything is actually potentially going to make it. Here's one that they've already said is not making it into C#11. So we talked about C#8 having the nullable reference types and checking for null. In this one, we're going to then say, as an input parameter to anybody that's calling this, you need to make sure that you have also made sure that you're not sending me null. And if you do send me null, then I'm going to have a problem with that. And to enforce that, then they added the bang bang operator. That's what people fought back against. And so that's why they are reevaluating this particular implementation to see, does this make sense or something? So if you feel strongly pro or con this, go out to the GitHub page. There's an issues list on that with a long conversation around it. Feel free to voice your concern about it. That's what open source is all about, right? Okay, one last one before we call it a day, and that is going to be static abstracts on interfaces. So if you've ever tried to create an interface that says, I want a factory method off of this interface to instantiate these things as static methods, and I want to enforce that all of my developers do this factory pattern in that same way for this kind of a thing, you couldn't do that before because an interface couldn't include a static definition. And so they are adding the support to now in your interface definition say that I want a static abstract method that then can be interpreted and be enforced into your interface as a static interface as well. And this is partly to allow for the use of that static iNumber in things that are static sum, static add, those types of things, to be able to support that on the interface itself. So some useful considerations. I think factory pattern when I come to this, but if there are other scenarios where you think that that's really going to be helpful, I'd love to hear your ideas on that. So, okay, actually we are over, aren't I? I was looking at my calendar thinking it was still counting down. It was counting up. So lots of stuff there. Didn't get into source generators. That's a really powerful feature. If I had 15 more minutes, we'd go into that one. But here's the link to the static resources. Of course, the most important thing is this last slide, or the last link, because it has a link to all of the samples and slide decks and everything like that. So hope you learned a lot. If you want to participate in the C# conversations, it's right there. Learning more about each one of these. The GitHub repo is up there for C#. What the status of any of these language features are there is all on this link. So lots of content there. Hope you learned some stuff. Take some stuff home with you and start playing with it, and have a great day.